Determine the validity of the argument P implies Q and R, not R, therefore not P. There are several different ways in which to determine the validity of arguments of this nature. Let's use the format used in your textbook, and we'll do so using truth tables. I'll start with 3 columns and assign truth values for each of P, Q, and R, and I need every possible combination. To ensure that, I will begin by giving truth value of true to the first 4 of P, and the last 4 I will give F for false. And then for Q, I'll do 2 by 2, so true, true, false, false, true, true, false, false. Now let's assign truth values for T, and we will alternate. So true, false, true, false, true, false, true, false. Notice we have 8 different possibilities. What I want to eventually get to is to determine a truth value for the first premise, which is P implies Q and R, and for the second premise, so I'll call that premise 2, which is not R, and the conclusion, which is given as not P. So now let's find the truth value first for Q and R, the consequent of P implies Q and R. So we'll look at the truth values. Q and R, true and true is true. True and false, false and true. When we have and, both statements have to be true, and so if we look at this quickly, we see that we get true twice. That's when Q and R are true, and again Q and R are true, and the rest are false. Now let's look at the implication. P implies. So we'll look at P implies Q and R. So T implies T, truth implies truth is true. Truth cannot imply false, so that's false. Third line, truth cannot imply false. Fourth line, truth cannot imply false, so that's a false. Now let's go to the 5th line. 1, 2, 3, 4, 5. False can imply true, so that's a true statement. Going on, false can imply false, that's true. False can imply false, that's true, and false can imply false, so that's also true. So we have the truth values for the implication P implies Q and R. Now let's get the negation of R for the premise 2. So we're just going to switch the truth values for the original R column, and we'll have false, true, false, true, false, true, false, true. And independently, let's look for the truth values of not P. So we're going to negate the truth values for the first column of P, which would give us false, 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 true, 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 true. And we now get to see 2 distinct areas in which the validity occurs. They occur at, let me count, 1, 2, 3, 4, 5. On the 6th one, we have true, true, and true. And on the 8th line, we have true, true, and true. And so we have demonstrated the validity. This is a valid argument.